Hello everyone, I'm Ninfa Bennington. I'm a volcano seismologist at the Hawaiian Volcano Observatory, and today I'm going to be talking about the seismicity that has occurred across the Big Island over the last year. To begin with, let's talk about the three major regions where seismicity distributes across the Big Island. So first, there's Mauna Loa Summit and its southwest and northeast rift zones. Kilauea Summit and the associated eastern rift zone. And then there's the Pāhala region here where we have both onshore and offshore events. Let's start by talking about Kilauea volcano. The 2018 eruption completely drained the lava lake that existed within Halemaumau crater. Following that eruption, we were left with the building of a water lake within the crater, shown right here. Then in December of 2020, we had a new eruption begin and the rebirth of the lava lake within Halemaumau. As we got into spring of 2021, the eruption quieted, and you can see here a dramatically cooled lava lake. However, in September of 2021, we had the resumption of eruptive activity and continued building of the lava lake. And as I talk to you today, we're seeing a period where we have pauses and restarts to this ongoing eruption. So the eruption might start again and the lava lake continues to build. Then we have these pauses where the lava lake cools, and we seem to be alternating between these two behaviors. Let's start by talking about the seismic activity that's been occurring at Kilauea Summit since the start of that December 2020 eruption. So first, we're going to look at the summit earthquakes that have been occurring there with depth. So here, each of these open circles represents an earthquake occurring at Kilauea Summit. And you can see them all across this profile. So our vertical axis shows the depth that these earthquakes occur. And we're going from 2 kilometers above sea level all the way down to 10 kilometers below sea level. Now the horizontal axis is showing time. So this red line here shows the onset of that 2020 eruption. And then as we move across this horizontal axis, we're progressing in time towards the time when the eruption quiets in the spring of 2021. The big takeaway here is we have the start of the eruption and with it, the occurrence of all this seismic activity, all these earthquakes occurring shallowly within the summit of Kilauea. Now as we progress into the eruption, we see that seismicity quiets. You can see here there's a real dramatic drop-off in the number of earthquakes occurring with time. Now we start to enter the spring of 2021, and we see the resumption of this seismic activity. We see more earthquakes occurring than were occurring before when the eruption was most active. And we see all this seismicity occurring, and the volcano continues to quiet and to cool. And then we get into the end of that eruption. Movies and TV have popularized what seismic data looks like when it gets recorded. So here in the left panel, I'm showing a classic seismometer, and it's recording these wiggles here, which are reflecting the amount of ground shaking going on in a particular place. And if that's big ground shaking, you get high amplitudes to these wiggles, small ground shaking, and the amplitude of those wiggles diminish. So folks are kind of used to looking at wiggles and thinking of them associated with seismologists. But actually, seismologists like to look not only at this sort of amplitude of wiggles, but also look at the frequency of the seismic data that we collect. So in the right-hand panel, I'm showing frequency data. So we're taking some window of these wiggles, and we're looking at them with frequency. So let me take you through these plots a bit. This vertical axis here represents the frequency of seismic waves from low frequencies, so starting at above 0 and going all the way to 20 hertz. The horizontal axis, again, represents time. So we start at time 0 for some time window we're looking at, and we go all the way to, in this case, 60 seconds or a minute out. Now I'm showing three kind of popular cases for the types of seismic data that we observe in the frequency domain. So if nothing's going on, there's no earthquakes occurring, there's no eruption, a lot of times what we see is this top panel here. So we have this bright orange and red color indicating that our strongest seismic signal is occurring here below about 1 hertz. And this will just continue on if there's nothing happening geologically speaking at the volcano. And that energy below 1 hertz is simply due to the crashing of ocean waves on the shore or the interaction of ocean swells with the ocean floor. So kind of the ocean hum going on our little island. Now what if there's an earthquake that occurs? Well, on top of this ocean noise that I just talked about, we get this energy arriving with both low and high frequencies. And you see here it kind of looks like this triangle shape. And this is the arrival of an earthquake at the summit of Kilauea. So besides those two kind of fingerprints to activity that's going on at the volcano, what else might we see? Well, during an eruption, if we have fluids moving within the shallow system at Kilauea, we often see these low frequency signals around 5 hertz and below. You see this orange and red color here. And that represents something called volcanic tremor, or the movement of shallow magma and other fluids through the shallow system within Kilauea summit. So in this way, the volcano leaves different sorts of fingerprints that we can look at and identify to know what kind of activity is going on at Kilauea summit. So now that folks have a basic understanding of what kind of activity is associated with a particular frequency domain, I'm going to start to show you the pictures in the frequency domain of the seismic signals we've recorded since the onset of that 2020 eruption. So first, let's look at the signal in the frequency domain that we recorded as the 2020 eruption started. And like that figure I showed you in the last slide, you see these high energy seismic signals arriving at about 5 hertz and below. And if you recall from before, that was something called volcanic tremor, and it was associated with magma and other fluids moving through the shallow system at Kilauea summit. And that jives really well with the onset of the eruption that we see here. So if we see these sorts of low frequency signals occurring, we often then look to other data streams to see if the volcano is erupting or inflating, any sort of indication that magma and other fluids are moving around and there's some sort of volcanic unrest occurring. Now let's look as we move into the eruption. We see the persistence of the most energetic seismic arrivals happening in this sort of tremor band. So again, fluid and magma is moving in the system. And then if you recall, with the resumption of earthquake activity in the spring of 2021, we had the start of quieting and cooling of Hale crater and the end of the eruption. And you can see with that, we lose that volcanic tremor signal, and our entire picture, what we see come about, is that ocean noise and nothing else. So we can actually really chart the eruption and the associated activity by looking at our seismic signals in the frequency domain. Now let's talk about volcanic activity that has occurred since the end of the eruption that began in 2020. So since that eruption's end, we've had the resumption of seismic activity or earthquakes occurring at Kilauea summit. You can see here as we're moving with time away from that eruption end. And if we look in the frequency domain, we see that that high energy seismic signal at frequencies of 5 Hz and below has disappeared. So we no longer have that volcanic tremor signal. And that makes a lot of sense, because if we look at Halemaumau crater, we can see there that it's obviously cooling and eruptive activity has ended. Now, of course, we also had this September of 2021 eruption that occurred, and we see here this large amount of seismic activity that occurred right as the onset of the eruption happened. And then following the onset, similarly to the 2020 eruption, we see that seismicity really started to dissipate dramatically as the eruption went on. And if we look in the frequency domain, we see that we have the appearance of volcanic tremor again, indicating fluids and magma moving shallowly within Halemaumau. And we can see that similarly in the picture here, where we have the resumption of building of the lava lake. And so that's where we're at right now. We have this ongoing eruption going on at Kīlauea, and as we've had pauses and resumptions in the lava lake activity, we've had both the appearance of the volcanic tremor and then moving towards an absence of the volcanic tremor and sort of going between those two behaviors. So that sums up what's been going on at Kilauea in the last year. Now let's move on to the Pāhala region, where we've seen a real change in annual rates of seismicity. If we look in this left-hand panel, I'm showing just a week of seismicity occurring in 2013. And in 2013, seismicity rates in Pāhala were pretty low. So here I'm showing this is a week of seismicity. This is generically outlining the Pāhala region. You don't see a ton of events. This figure in the top panel is showing weekly counts of seismicity. This vertical axis shows the weekly counts, and the horizontal axis shows time. So you can see in 2013, the amount of earthquakes occurring was pretty low relative to the amount of earthquakes that you see as you move later in time. Let's move to 2017, or even let's look earlier. You can see that by 2015, relative to earlier years, we're starting to see an uptick in the number of earthquakes occurring per week in Pāhala. And I'm showing here this middle panel. This shows a week in 2017 of seismicity on the island. And so you can see here, I'm just sort of generically outlining the Pāhala region, that again, seismicity is slightly increased relative to the distribution of events happening in this region in 2013. But the real jump happens in sort of mid-2019, and you can see the number of events being counted in the Pāhala region really starts to take off to dramatic levels. So if you see here in this right-hand panel, this is just a week of seismicity occurring in Pāhala in 2021. So it's an extensive amount of seismicity. So what could this swarm or high number of earthquakes occurring in Pāhala mean for the region? What could it represent geologically? There was an interesting study done in 2015 by scientists at the USGS where they postulated this very question. And they looked at not only those earthquakes occurring, but they also identified tremor, similar to what I was talking about earlier at Kilauea, but at this time occurring within the Pāhala region. And this tremor was located deep, about 40 kilometers below Pāhala. And as I talked about earlier, it's often associated with the movement of fluids and magma. Now, right above this tremor that they located were all those Pāhala earthquakes that I was showing you in the previous slide. And when you plot those and look at them with depth, they form a nice linear chain. You can actually see even better in this figure above, moving towards Kilauea. And they hypothesized that this region represents a mantle fault zone towards Kilauea, where perhaps these magmas and fluids move towards the region and perhaps even act as a source for deep magma into Kilauea. Of course, this is currently a hypothesis, and permanent stations that HVO has in this region are fairly sparse. If USGS can densify the number of stations or seismometers within the Pāhala region, at least temporarily, we can then start to image the structure of the subsurface in this region in order to better understand why we are having all of these seismic events. And so that's a future project happening with the USGS, likely beginning this spring or summer, where we'll be placing these very small seismometers densely through the Pāhala region, collecting data for a few months, and then using that data to model what the subsurface in the region looks like, so that we can try to better understand what's going on at Pāhala and the reason for these swarms of earthquakes. With respect to island-wide seismicity, let's finally look at Mauna Loa. In spring of 2021, it produced seismic swarms. Those are most easily seen if we look at this plot of earthquakes per week. Again, that count's going to be on the vertical axis versus time. So in the spring of 2021, we had these upticks in weekly seismicity, and that went down following the spring to these lower rates seen here as we march in time to the present. These swarms plotted in two regions. Here, across Mauna Loa summit, with this northeast-southwest trend, and then also a second region of events, here located immediately west of the summit. And these are two common regions where we see seismicity, whether in a swarm level where we have lots of seismicity occurring, or just kind of weekly low levels of seismicity. Following these swarms, though, we've gone into this period of very low activity at Mauna Loa, with not much going on. Finally, we move offshore to Luihi Seamount. This newly named submarine volcano is located immediately east of the south point of the island of Hawaii. And in the last several weeks, it's had a swarm of seismic events occurring there. This culminated in a magnitude 4.9 event in this region. And these events may represent either the intrusion of magma and fluids into the volcanic system there, or volcanic activity. At this time, due to the fact that we're observing these events from our network of onshore stations, we can't differentiate between the two. This concludes our summary of seismic activity across the Big Island for this month's Volcano Awareness Program. Thank you very much and have a wonderful day.